All right, let's just jump right in. Something huge is happening in the world of cybersecurity right now, and I'm not talking about just another software update. No, we're talking about a fundamental rewiring of how we find and fix security flaws, and it's all being driven by a totally new kind of AI. And it all kind of kicked off with this one single claim from a new tool called Claude Code Security. This one phrase, bugs that had gone undetected for decades, sent absolute shockwaves through the entire tech industry. Think about that for a second. An AI that can find critical security holes that thousands of human experts on all our existing tools have missed for literally decades. This wasn't just a product launch. It felt more like a warning shot. And if you want to see just how real the impact was, look at this. The moment this news dropped, the market freaked out. Check out the stock prices for established security giants like CrowdStrike and Okta. They took a serious, noticeable hit. And why? Because investors saw the writing on the wall. This new AI had the potential to completely flip the entire business of cybersecurity on its head. So what's the big deal here? Why such a dramatic reaction? Well, the key thing you've got to understand is that this isn't just another scanner checking off a list of known problems. This is what we call an agentic AI. It's built to actually reason about code, to think about security problems in a way that's much, much closer to how a human security expert thinks. This slide has a perfect analogy for it. The old way, the way we've been doing it for years, is pattern matching. Think of a security guard at a building with a checklist. Is this door locked? Yep. Is that window closed? Check. It's great for spotting things you already know to look for, but it completely misses anything subtle or new. This new way, semantic reasoning, is a whole different ballgame. It's more like a seasoned detective showing up at a crime scene. The detective isn't just looking for clues, they're trying to understand the motive, the relationships, the logic of the entire situation. This AI understands what the code is supposed to do, which lets it find these incredibly deep, hidden flaws. And if you're thinking, okay, that sounds cool in theory, but does it actually work? Well, here's your answer. Over 500. Anthropic's team pointed this AI at major, widely used open source projects and found over 500 validated high-severity bugs. And let's be clear, these weren't theoretical maybes or false alarms. These were real, confirmed vulnerabilities that developers agreed were serious and had been hiding out in the open for years. So let's break down how this AI actually thinks. Take the Ghostscript library, for example. The AI didn't just scan the current code. No, it went back and read the project's entire history of bug fixes. It saw a patch from a while back for something called stack bounds checking, and it reasoned, just like a human researcher would, if they fixed it here, maybe a similar problem exists somewhere else they forgot to patch. And bam, it found one. It even created a special file to prove the bug by making the program crash. Or check this one out, the OpenSC project. Here, the AI found a classic type of bug, a buffer overflow. But here's the twist. It didn't just flag a function and say, this is bad. It understood the context. It figured out that using this function over and over again, over time, could eventually cause a memory overflow. It's that kind of subtle, long-term interaction that human eyes can so easily miss. Okay, this one is just wild. This is my favorite. With the CGIF library, the AI proved it could understand really high-level, complex computer science concepts. It dug into the LZW compression algorithm and found a purely logical flaw. It found a bizarre edge case where the compressed file could actually end up being bigger than the original file, causing a crash. A normal tool that just throws random data at a program would probably never, ever find a conceptual bug like this. All right, so this AI is obviously incredibly powerful, which of course leads to a pretty urgent and frankly kind of scary question, right? How in the world do you control something like this? How do you let a powerful AI into your most sensitive code without it, going haywire and wrecking the place? Well, the answer is you put it in a very, very strict digital box. The whole system is built around a super tight permission framework. By default, the AI is in look but don't touch mode. It can read files to understand the situation, but that's it. Every single action that could possibly change something, editing a file, running a command, requires a human to look at it and explicitly say, yes, you can do that. This whole human-in-the-loop thing is the main guardrail keeping the developer in the driver's seat. And that idea is central to how it actually patches bugs. The AI does all the heavy lifting, all the tedious work. It finds the bug, it double-checks to make sure it's not a false positive, and it even writes the code to fix it. But then, it stops. It presents everything on a dashboard for a human to review. And this is the critical part. No code gets changed,
nothing gets applied until a real developer looks at it and gives the final okay.
On top of all those permissions, there are some serious technical lockdowns in place. Every single session runs inside its own isolated virtual machine, its own little digital bubble. This is huge because it prevents the AI from ever escaping and wandering off to access sensitive things like system files or passwords or API keys. But, and you knew there was a but coming, right? This is where the story gets way more complicated. Because as groundbreaking as this technology is, it is far, far from perfect. In fact, this new agentic approach brings a whole new set of weird and challenging problems to the table.
So we have to ask the tough question. With all this incredible reasoning power, how reliable is it? Like, for real. Can we actually trust its judgment every single time?
This chart really tells the story. The AI's performance is, well, it's all over the place. For certain kinds of bugs that require a lot of context, it's actually pretty good. A 22% true positive rate is nothing to sneeze at. But then you look at a classic, well-understood bug like SQL injection, and whoa, the accuracy just plummets to a measly 5%. It's brilliant at some things and, honestly, pretty bad at others.
And then there's this really bizarre problem called non-determinism. Basically, it means you can run the exact same scan on the exact same code 2 times in a row and get a different number of results. It's like asking a creative person to brainstorm ideas. You might get 3 amazing ideas today and 10 tomorrow. This makes it a fantastic tool for discovery, but it also means it can't replace our old, boring, but reliable scanners that give you the same answer every single time.
And that's not even the end of it. We're dealing with entirely new kinds of risks here. Its reasoning can be a black box, so it's hard to know how it made a decision. It can be tricked by malicious instructions hidden in a code file. That's called prompt injection. And get this, sometimes it will find a totally real, legitimate bug and then run a bad test and convince itself it was wrong and dismiss its own finding.
So, where does that all leave us? We have this incredibly powerful, but also kind of flawed and unpredictable new tool. But the industry isn't giving up on it, not at all. Instead, what we're seeing is the beginning of a whole new model for how security work is going to get done in the future.
First, we have to get this distinction clear in our heads, the difference between an assistant and an agent. You probably use or have heard of GitHub Copilot, right? That's an assistant. It helps you line by line in one file. It's an autocomplete on steroids. Claude Code, this new thing, is an agent. You can give it a complex goal that spans dozens of files, like fix this security bug, and it will work on its own, autonomously, until the job is done. It's a whole different league. And this all leads to this really cool concept called the Agentic SOC, or Security Operations Center. This is the vision for the future. It's a world where AI agents are embedded right into the development process. Just imagine them automatically handling the vast majority, maybe even 90% of all the routine, annoying security alerts. This would free up the human experts to focus their brainpower on the really hard, really strategic, high-level threats. Now, this completely changes the job description of a developer. Your job shifts away from just being a hands-on keyboard coder. You become more of a high-level architect. You're the one designing the systems, defining the goals and the rules for your AI agents. And, most importantly, you're the one validating that what the AI produces is safe, correct, and actually does what the business needs it to do. You become less of a builder and more of a supervisor. So, let's be super clear. The ultimate goal here is not to replace human security experts. Absolutely not. The real magic, the real future, is a hybrid model. It's about combining the AI's incredible speed and reasoning with the essential common sense, oversight, and final say-so of a human expert, all while being backed up by those reliable, old-school deterministic tools. And that really brings us to the final big idea. We've kind of moved past the question of if AI can write and secure our code. It's pretty clear now that it can. The defining challenge for our generation of developers and security pros is now a question of governance. How do we, the humans, design the systems and write the rules to safely and effectively manage these incredibly powerful new agents?